I look at is relationships between the immune system and dystrophic muscle. And the reason I do that, and the reason it might be useful for developing treatments for Duchenne dystrophy, is that what we've learned over the past, 15, 18 years is that the immune system can play an important regulatory role in determining how severe the pathology of Duchenne dystrophy is. What our data have shown is that an important triggering event is in going from the essentially subclinical disease to one that's rapidly progressive is when the immune system gets involved and essentially overreacts to the pathology. So the encouraging feature of those observations is what they tell us is that we could manipulate the immune response, that we could control the pathology and maybe damp it down to a condition that's maybe not life-threatening. But then, as we learn more, so because we were learning about the complexity of the immune involvement in the disease, what we found is that there are also other populations of immune cells that aren't making things worse, they're actually making things better. So they're promoting muscle regeneration. So any intervention that you design to affect the immune system, if you just blindly suppress the immune cell involvement, you might get rid of the cells that are increasing damage, but then you could also be getting rid of the populations that are promoting regeneration. So what we're trying to learn now is the identity of all the specific subpopulations and how they do bad things or good things, so we can separate them out to target them individually and try to get rid of the bad guys and encourage the good guys.
My name is Ilkana, and I do research in Dr. Pyle's lab at UCLA. And our lab is interested in developing a potential therapy for Duchenne muscular dystrophy. And one promising way to develop this therapy is to undergo this cycle. And so we're interested in taking cells from patients, induce pluripotency, and derive skeletal muscle cells from human pluripotent stem cells and transplant those cells back into patients. And my project is specifically in this step where human pluripotent stem cells are differentiated into skeletal muscle cells. And so I'm doing in vitro differentiation.